This video we're going to look at index laws. Now, an index number has got both a base and a power. So here we've got a to the power of m. A is the base, m is the power. Okay, we're going to look at a few laws for index numbers. The first one, it says a to the power of m times a to the power of n, and you can see what you've done is you just add the powers. Next one says a to the power of m divided by a to the power of n, and you can see you've just subtracted the powers. Next one, we have got a to the power of m all to the power of n, and what we've done here is we've multiplied the powers. Next one, we have a to the power of 0 is equal to 1. So that just means any number to the power of 0 gives you 1. And the last one, the trickiest one we have here, is a to the power of minus m is the same as 1 over a to the power of m. Why that one is, let's have a look. We'll just pick a number. We'll pick 2. So we use 2 for our binary system. 2 to the power of 0 then is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. That's as far as we'll go. We're just going to write those out, and then we're going to go work backwards. So how you work backwards, that's 4 and 2. So what you're doing is you're dividing by 2. 2 to the power of 0 is 1. So the next one, logically, the next one would be 1 over 2, and the next one would be 1 over 4. And if you work backwards, again with the powers up above, here we had 2 to the power of 2. Here we had 2 to the power of 1, 2 to the power of 0. So if you subtract again, you're going to have 2 to the power of minus 1, and you're going to have 2 to the power of minus 2. And another way, just to prove it then, another way we could write this one is 1 over 2 to the power of 1. Another way we could write this one is 1 over 2 to the power of 2. So you can see then that 2 to the power of minus 2 is the same as 1 over 2 to the power of 2. Likewise, 2 to the power of minus 1 is the same really as 1 over 2 to the power of 1. We're going to look at some examples now and how we can simplify. So simplifying indices is really easy if you use your rules of indices. So the first thing I've got, a bit like your BIDMAS, we will just do the brackets first. Inside the bracket, you've got a to the power of 5, times a to the power of 6, which is a to the power of 11, and then that's raised to the power of 3. So raised to the power of 3, that means you multiply those powers. So 11 times 3 is 33. Next one along, very easy one, it's just c to the power of 5 divided by c to the power of 8. I'm just going to write that as c to the power of 5 minus 8, which just becomes c to the power of minus 3. That's still in index form, but you could write that one as 1 over c cubed. But in index form, this one is what you want. Next one, sort out your numerator and sort out your denominator. So I'll do my denominator is g to the power of minus 2. A lot of people make a mistake in this one. It didn't have a power here, but the power really is 1. So the top line really is g to the power of 6. And we'll just write this out the long way. That's g to the power of 6 minus 2, which is the same as g to the power of 6 plus 2, which is the same as g to the power of 8. Next one, we've got numerical problems coming in. We have 3 things going on here. You've 4, it's multiplying 3. 4 times 3 is 12. Next thing we've got is y to the power of 3 times y to the power of 1. So if you did that, it's going to be y to the power of 4. And the last thing you've got is z times z squared. Z times z squared is just going to be z cubed. A lot more going on in this example. First thing you've got is you've got 2 times a to the power of 8, and that whole thing is being squared. So we have to, that means you've got to square the 2 and you've got to square the 8. So really we could write this as 2 squared times brackets a to the power of 8 squared, and then times 3a to the minus 3. 2 squared is 4. A to the power of 8 all raised to the power of 2. Multiply those powers, you'll get 16. And then times 3a to the minus 3. Then just sort out the numbers, then sort out the indices. 4 times 3 is just 12. And a to the power of 16 times a to the power of minus 3. Add the powers, 16 plus minus 3 is the same as 16 minus 3. So it is just 13. Next example says, write the following in index form So that means a to the power of something. So the first one we have is 1 over 2. I could write that first of all as 1 over 2 to the power of 1. And using my laws of indices, that's the same as 2 to the power of minus 1. Next one, we have 3 over d to the power of 2. So that's the same as 3 times 1 over d squared, which is the same as 3 times d to the minus 2, same idea as before, which is 3d to the minus 2. Next one, again, we can write that as a half times 1 over m to the power of 5, which is a half times, and that's the same as m to the power of minus 5, which is just going to be, I'll just write that as a half m to the minus 5. This example says we can use our index rules to evaluate, which just means find a value of. So you've see the word evaluate just means work it out as a number or a fraction or a decimal. So it says without the use of calculator, evaluate, and we've got a few things to do. So first one, dead easy, it's 25 to the power of 0. Anything to the power of 0 is 1. Next one, you could do this a couple of ways. I think I would just work out the bracket first. 2 cubed means 2 times 2 times 2. 2 times 2 times 2 means 8. And then squared, 8 times 8 gives you 64. Next one says 2 to the power of minus 3. So that's 1 over 2 to the power of 3. And 2 to the power of 3, 2 times 2 times 2 gives you 8. So it's 1 over 8 as a fraction. Next one is 4 to the minus 2. That's 1 over 4 squared, which is 1 over 4 squared is 16, so it's 1 over 16. Okay, I'm going to show you a couple of ways of doing this one. One way is okay, but the next way is much, much nicer. Now, what you could do is sort out this minus power. So, sorting out that minus power means what you would do is you would write that as 1 over, and your bottom line, you've got a fraction squared. Now you could sort that out and say that's 1 over and a half times a half. Just write that here. A half times a half is multiply along the top to give you 1, multiply along the bottom to give you a quarter. Sorry, to give you 4. So a half times a half is a quarter. So you got 1 divided by a quarter. Now how do we divide by fractions? So what you really have is 1 divided by 1/4, which is the same as 1 times. Flip your dividing fraction, change it to multiply. So it's 1 times 4 over 1 is just 4 over 1, which is just the same as 4. Okay, that is fine. It's an okay method, but there is a nicer method to do this question. So, or what you could do in this situation is just say that that is the same as, so you can get rid of the minus, so that just becomes to the power of 2, but you flip your fraction. So your fraction becomes, instead of 1 over 2, it becomes 2 over 1. And in this case, this particular case, that just becomes 2 divided by 1 is just 2, and 2 squared is 4. Now where that one would be particularly useful would be, say you had, it wasn't something just as nice as that, say it was 3 over 2 to the power of minus 2, you would flip it and it would become 2 over 3, but now to the power of 2, and square the top line, you'll get 4, square the bottom line, you will get 9. So it's definitely a much nicer method than the first one. Our last example for this video says express 8 to the power of 4 times 16 to the power of 2 all over 2 to the power of 5 times 4 to the power of 3 as a single power of 2. Difficult example. So we've got to change, first thing we've got to do is go through and change all of our different numbers so that they are have a base of 2. So 8, it's just a wee bit of working out, 8 is the same as 2 cubed, 16 is the same as 2 to the power of 4, and 4 is the same as 2 squared. So instead of 8, we're writing that 8 becomes 2 cubed, and then it was to the power of 4. Instead of 16, it was 2 to the power of 4, and then it was to the power of 2, or We have 2 to the power of 5, it's already sorted. Our 4 is 2 squared, and then it was the power of 3. Okay, that's an absolute mess, that's sorted out. Top line becomes, we have 2 cubed to the power of 4, that becomes 2 to the power of 12. Bottom line becomes, and then we've got 2 to the power of 4 squared, so that becomes 2 to the power of 8. Bottom line, we've got 2 to the power of 5 times, and that will become 2 to the power of 6. Sorted the numerator, it would be 2 to the power of 20, and your denominator is going to be 2 to the power of 11. And then that will become 2 to the power of 20 divided by 2 to the power of 11 is 2 to the power of 9.